let's look at the blue graph and determine if it's an inverse for the pink graph. Well, let's look at one of the points here. Well, the first point I see here is the point 0, 4. What does that mean the inverse should have as a point? Well, it should have the point 4, 0, which it does. Now again, let's look at the original points for the graph F, the blue graph. It also has the point 3, 0, which means that the inverse should have the reverse. The inverse should have 0, 3, which it does. So, are we thinking that these are inverses? Yes, because it does appear that all of our points have been swapped, the x's and the y's. And it does appear that the two graphs are a reflection over the line y equals x. Let's look at the last example here. What if we actually have a graph of a function? How would we graph its inverse? Well, again, remember anything that's on this line here, the line y equals x will stay the same. So the first point that's on that line for our graph that will stay the same is the origin, 0, 0. If you swap around 0, 0, it will stay the same. Notice it also goes to the point -2, -2. Swap that around and it would be still -2, -2. Now notice the part of the graph that is below the line is going to do what? It's going to flip above the line. And the part that was already above the line should flip below the line. So it just creates a mirror image of the same shape, just flipped over that line. And so let me label that pink graph, my new graph, as my inverse.